Part 2. Now, prime numbers and composite numbers are the two main types of numbers that we work with that are integers. And prime numbers are divisible by themselves and by one only. We're going to come back with some examples of those in a minute. Composite numbers are divisible by other numbers as well, not just one in themselves. Every number is divisible by itself and 1. 15 is divisible by 15 and 1. But it's also divisible by 5 and 3, so it is a composite number. And as opposed to something like 7, 7 is divisible only by itself and 1, so it is a prime number. There are literally hundreds of prime numbers, but the ones we will be primarily working with are 2, 3, 5, and 7. Now, in terms of that, just looking at this number chart here, if you look, the idea of prime numbers here, this one here, prime. Prime. Is 4 prime? No, it's 2 times 2, so it's not prime. This is prime. Any number that's even is going to be something that's times 2. So we start getting there. Now 9 is not a prime number because it's 3 times 3. And there get to be fewer and fewer prime numbers as we go through. 11 prime, 13 prime. 15, not prime, 3 times 5. And we can just skip the even numbers. 17 is prime. 19 is prime. 21, no. 22, no. 23, yes. And so on. And we could just do this for a while here. No, no, no. Think about what's divisible by it. This is 3 times 9. 14 times 2. This one here, prime. 31 is prime. Nothing. The only two numbers that you can multiply together to get 31 are 1 and 31, and so on. So we go through this whole thing and come up with all the prime numbers, but the primary ones we're going to be working with a lot are going to be 2, 3, 5, 7, and 11. The other ones we just will not touch on all that often. So here's what I want to look at from here. In terms of prime factorization, one of the ways that a lot of people like to do it is just to draw what's called a tree diagram. So 15, well, what is 15? 15 is not a prime number. It's a composite number. We know that. So it's going to be 3 times 5. And I like to circle them just to make sure I know I'm done. The reason why I'm circling them is because I know 3 is a prime number and 5 is a prime number. Then I can just write it out as 3 times 5. Now 24, same sort of thing here. All I think to myself is, what two numbers multiplied together equal 24 that are not 24 and 1? So generally I like to start with even numbers just with 2 because I know that that's easy and it's going to work. So 2, there is a prime number. 12, is 12 a prime number? No, it's not. So I'm going to go ahead and divide it by 2 again. And then I have 6 over here, and I've got 2 as well. Here, 6. 6 times 2 equals 12, just like 12 times 2 equals 24. The two numbers that are linked together should multiply to equal the number that's above it. So this is going to be 2, which is prime, and 3, which is prime. So if we were to write out 24 in prime factorization terms, we'd do 2 times 2 times 2 times 3. Which makes sense because it's 8 times 3. Or I could write it out using exponents, 2 to the 3rd power times 3. Now just to show you how easy this is to go ahead and do, and as long as you divide by the right numbers, you always end up with a right prime factorization. I'm going to show you a couple of different ways that this is done. For example, here, 120. That's equal to 3 times 40. I know that because 1 plus 2 plus 0 equals 3, so I know it's divisible by 3. This one here, 40. I know it's going to be 4 and 10. Are either of these prime? No, they aren't. So I have to keep breaking it down until I get to actual prime numbers. 2 times 2 equals 4. And 2 times 5 equals 10. And if I write this out, it's going to be 2. And sometimes I like to just make sure that if there's a lot of them, to cross them off so I don't double up where I shouldn't. It's 2. and I like to do it in order in terms of least to greatest. So I start with my 2's, then I go to my 3's. Okay, so this is going to be 2 to the third power times 3 times 5. Now this one here, 120, again, same sort of thing, but just to show you that it works, no matter how you do it, we're going to go ahead and do this slightly differently. If I wanted, instead of doing 3 times 40, if I wanted to do 6 times 100, or 6 times 20, that still equals that, so that still works. But here, neither of those are prime, so 3 and 2. Well, both those are prime. This is going to be 5, or 4, times 5. 5 is prime. 2 and 2 equals 4. So either way, I'm going to end up with the same thing, because if you look here, I still got 2 times 2 times 2 times 3 times 5. And that's going to be 2 to the third power times 3 times 5, which is exactly the same as I got over here, which makes perfect sense because this does multiply out, and it equals 120, and so does this. So it doesn't matter how you approach it, which thing you start dividing with. I could start by dividing this by 2 and end up with 2 and 60 over here, and I would still end up with the same prime factorization if I followed it through to the end the right way.